everyone. I'm Pooja Gupta, Digital Marketing Manager at Data Gaps, and thank you all for joining us today for this webinar on addressing the post-go live slump, why SAP systems feel slow and how to fix it. Before we begin the webinar, here are a few quick housekeeping notes. This session is being recorded, and the recording will be shared after the webinar. To ensure a smooth experience, all attendee microphones and cameras are turned off. We will be launching a few live polls during the session, so we encourage you to participate and share your feedbacks. If you have any questions, please submit them during using the Q&A panel, and we will address them during the Q&A session at the end of the webinar. Build resilient, high-performing SAP environments through modern performance in engineering practices. Now, on the panel today, we have Nagarjuna TA, Director of Engineering at ImpactQA. And Nagarjuna, stage is all yours now.
Thank you so much, Pooja. Hello, everyone. My name is Nagarjuna, and I'm the Director of Engineering at ImpactQA, where I lead the performance engineering services. I have an extensive experience in managing the performance engineering services, and largely SAP Greenfield and Brownfield implementations I've done for large organizations, helping them ensuring the applications are scalable, reliable, and production ready. I have 20 years of experience in software industry, and I had an opportunity to work with leading global organizations such as American Express, JP Morgan Chase, and NBC Universal before joining ImpactQA. I'm really excited to be part of today's webinar and looking forward to share my experience and insight with you all. So let's get into our presentation. This particular presentation that we'll be going through is addressing the slump, the post-go live slump. Now, why SAP system feels slow and how to fix it is what we'll be discussing today. Now, we'll cover in today's presentation why the slump is predictable. Second, the common cause of this particular slump. Third, what are the points that cause the slump? We are going to decompose them. We are going to break it down and try to understand the cause of the decomposition, the cause of the slowness. Then we'll see the database, middleware, and infrastructure. These are the mean potatoes where you will have the problem sitting in. Next, we'll measure the user experience. Now, from where we get this particular statement, the application is slow, mostly from the user. So we need to look from the user perspective, what they are experiencing. And last but not the least, what is new in 2026 and 2027 that is coming up. So this is what we will be covering for today. Now, I'll be moving to the next slide. Now, why go live is exactly when performance falls apart. Like every ERP program celebrates cutover as their finishing line. But for the people who support the application, it is a starting point. The slump that follow is not a bad luck. It is a predictable collision of three things that were approximately right during the project execution, but become wrong in production. What are those three things that was right in project, but gone south during production? The first is the data volume crosses the threshold. The test system runs on a sample data. So the project that we will be doing, we will have the test system. And the data that sits into the project is limited. The test system runs on a sampled size of data. On a day of production, the tables are full size. And the optimizer plan that looked fine for 100K rows of data falls apart when it goes to production with 100 millions of data. That is the topmost challenge. The second one is concurrency become real. The performance test we conduct with 200 concurrent users with scripts does not reproduce the actual human hitting month end closure, wherein you will have the EDI burst happening or batch files running, log contention happening, buffer weights, all these things are happening in real time. You are not able to simulate all these scenarios in your test environment. And the third one is the cache and buffer cold start. So when you start fresh, your system is empty. All the cache are empty. All the requests will be hitting your system of records. And from there, you will be getting the data. So what you have experienced during the testing is not what you're seeing right now in production, because there is no cache initially. So when you land initial days, that is a time when you see the slowness, and that is a time when people started complaining, saying that application is slow. So these are the three common factors which you can predict, saying that data volume, concurrency, and cold cache cause the slowness. Now, we'll move to the next slide. When people started complaining about the slowness, there are common cause for the slowness. When you see an application going slow, the typical symptoms, I have listed down the key typical symptoms and the cause and the layers that are probable area of interest to for us to look in. For example, the first one, a handful of transactions suddenly it started taking 100 seconds or 100x time more than what we have seen in the test environment. That can be stale optimizer statistics. If that is one of the cause, it is at the database level. The other symptom, specifically reports or screens become slow, means your CPU and input output spikes on the database. The cause is expensive SQL or bad execution plan. Again, we have to go to the database. Database is the area that need to be looked in. The other symptom that you see, high physical reads or low buffer hit ratios or broad slowness, it is the misconfigurations. So configuration is not done properly or undersized configuration. It is like app servers that need to be looked in or DB servers that need to be looked in. There's another symptom that users queues, dialogue responses, time climb at peak. So all requests are getting queued up. Now, when all requests are getting queued up, it's an application and middleware issue. Similarly, the slowness, the applications slow down at a specific time of the day. So we might need to look into any batches are running or anything is happening at that particular time, because that particular slowness happen at a specific time of the day. So this is something which is a workload management that we need to look. Now, new functionalities is slow. Say, for example, if newly developed functionality like Z code or Y code has been introduced as part of the project, if they are slow, then definitely we need to start looking into the code for Z and Y code. So it is approximately the application that we need to look. The shortcut is sudden slowness in few transactions. It is the database. It can be a stale stats or a bad plan. But if everything is slow all the day, look into your infrastructure. That is the common cause. Now, the next is, once you find out that what issues you are facing, then you need to start looking into the area that will give you more information. Now, we are talking about decomposing the response time. First thing is, resist your urge to jump straight into the database, um, that is like SAP HANA. So whenever you see slowness, don't start jumping onto the database and start saying that, okay, let's look into the database. The first and the foremost thing, SAP has its monitors. So look into SAP monitors, drill down into the details. The single most important habit, or the most important thing that need to be done, is decompose the response time. So break down. Go and see the response time, the round trip time of a request. Go and see what is the breakage of that particular response time. That you can do using ST03N. This particular T code will tell you the time taken for that particular what you call transactions and at the layer. Now, each particular round trip will have a wait time, that is queue time in the dispatcher. Second, roll in time, that is the memory transfer time. Third is the load and generation, the program buffer time. Fourth is a database request time, the time taken for a query to run. Fifth is the processing time, how much ABAP CPU took to process that particular time. Sixth is a queue lock contentions. And seventh is the round trip, complete round trip time. So all these things are like area of interest for a person who is looking into the slowness of that particular transaction. Say, for example, if you have a high waiting time, what does it mean, high wait time? Not enough free work process or requests are queued in the dispatcher. So you mean to say that your request is getting, when is waiting for resource to get allocated so that it get processed. So this is not a code problem. This is a capacity or a configuration problem at the infrastructure level. The next one, we can say that in your what you call decomposition, you can see high database request time. The 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 high database request time will tell you the time taken by the database to process this particular request. The main aim is to look into the DB cockpit. Look into the DB cockpit, and it will give you the detailed breakdown of what are the top 5 SQL statements that are consuming your time and all those things. Similarly, high processing. If you see in the response time, high processing time, this is something which is coming from a website most probably. It can be a bad coding where they have written a loop inside loop, or they might have done too much looping in the tables. So this can be one of the reason why your CPU utilization is more. So go to SAT or ST30 or ST05, and it'll provide you more information, like where it is taking more time. Similarly, high roll in wait time. So roll area extend like memory pressure or wait for RFC or GUI round trip. So these decomposition and analyzing these decomposition will help you in understanding where exactly you can go and do your deep dives. So these each component point to a different owners, and we have a different tools for doing this. Now I'll move to the next slide. This particular slide will talk about the sequence of doing the triage. Now whenever we have a particular area that is causing the slowness, first thing that we have to run is ST03N for the affected window. Which transaction dominate which response time component, it'll provide the details. Then you look into your DB time. If DB time dominates in your what you call response time breakup, then you might need to go and do ST04 DB log in HANA DB log cockpit for the top SQL and wait events, reproduce with ST05 SQL trace and actual slow steps. Other one is CPU processing. In your breakdown, if CPU processing is dominating, then you might need to SAT to find hot ABAP areas and usually try to find out like if there are like nested loops or some other bad practice of coding. In case if there is a wait time dominance in your response time, then you might need to run SM66, which will help in finding out like WPBG time and other things. Similarly, cross-checking the dumps. So cross-check your SC22 and SM21, the system logs, for dump and errors that correlate with slowness of the windows that is captured. So run this sequence every post go live ticket. It converts a vague system slow into a specific measurable bottleneck in a minute, not in hours. So this particular repeatable process can help you in getting the RCA quicker. And don't forget, read the early watch alerts every week post go live. If flag growing table missing index and expensive statement usually before your what you called before users started experience these particular slowness. So this particular triage will help you out in that. Now the next one that we want to get into is the area which causes the major slowness, the database. The database is where most dramatic slowdown happens. The diagnostic is the same whenever run underneath the SAP. Find what database is waiting on. Find and then find what SQL is responsible. On the modern SAP landscape, the database usually like SAP HANA and SAP Service, it always uses cockpit. So go to the cockpit and get the details of what is the cause of the slowness. DBA cockpit and SAP HANA cockpit studio performance view are the front door for CPU, memory, threads, and all the block transactions. You can find the expensive statement trace, SQL plan cache, thread and sessions, and load history with all these particular cockpits. You can get this information. Similarly, in the middleware, where ERP, I mean, if you see, the middleware, ERP slowness is not frequently in SAP or in the database at all. It is the plumbing work or the place where it is integrating with outside world or the third party. That is the place where you see most of the slowness. So start looking into SAP dispatchers or load balancers. Try to see what kind of load balancing algorithm is used in that particular load balancer, and see whether the load balancers are properly distributing the load to all the nodes which are available for the utilization. Sometimes it may happen that they may not be using the right load balancing algorithm, and few of the nodes are getting more traffic compared to other, which might be one of the reason. The other thing is OData, the gateway OData. In SAP Fury, the round trip is captured through browser. So you might need to start looking into the OData calls. You might need to see the time taken by these particular APIs for particular slowness or for particular response time. So this is something which you need to start looking into the middleware and the integration part of SAP. SAP has a lot of integration systems. So that is one of the area which generally cause the slowness. Then infrastructure. SAP infrastructure, like you can see the CPU saturation and the queues are getting filled up. That is one of the area where the slowness is introduced, and that cause the end user experience bad. So CPU busy, we might need to start looking into how these CPUs are utilized and how this particular node is getting is getting the traffic from the front ends. Similarly, the memory and the storage latency. Apart from that, network also plays an important role in this particular slowdown. So these are the three key areas that generally causes the slowness. in the application. Now, coming down to the next slide. Now, this particular slide talks about the user experience, the user monitoring part of it. So, whenever we get a particular metrics from our basis team or from the infrastructure team that everything is looking green, we might need to understand one part, that system side metrics is measured based on average response times. Now, whenever you have a situation where metrics are shown green, but there are a lot of requests coming from client side that application is slow, definitely we are not looking onto the right metrics. So we need to look into the details, like what metrics we are getting. Is that like an average metrics or a percentile metrics? So we always need to look at the percentile metrics, because if you see an average response of 1.2 seconds can be seen in another way, that percentile 99 can be approximately 3 or 4 times of what is the average, because of those spikes or the big tails. So we have to start digging into the details of percentile. We need to see what is the gap between average time and the percentile. It may happen that users might be experiencing the percentile 95 or percentile 99, not the average one. So average one is not right measure when you're checking the performance of the application. So it's better that you use real-time user monitoring to see the user experience at different geolocations, and try to have synthetic monitoring to generate the synthetic traffic at regular intervals on the day, and capture how the functionalities or the key functionalities are working during the day. That will help us out in measuring the client side response or rendering, and can help us in identifying those spikes, or those what you call the exception time, where people are experiencing the slowness. Now in the slide you can see average look good, but when you see percentile, they are spiked up. So they are approximately 3 to 4 times, or sometimes 5 times, depending upon the spikes. And that is where the users are experiencing, and our metrics are talking about average, which is always green. So what you measure is really important here. The essence is we have to start looking into the percentiles when we are looking into the performance of the application. Now let's move to the next slide. Now, these are some of the real-time examples that we have seen in this particular greenfield and brownfield implementation. The first one is case A, day 3 cliff. The scenario was like manufacturer's order screen went from sub-seconds to 30 seconds, 3 days after go live. So ST0N showed DB time dominate. So what we did, we started breaking down the response time. And when you start breaking down the response time, we identify the DB is taking a major chunk of the response time. So we went into the DB cockpit and we tried to identify the most expensive SQL statements that are taking time. And then we found out that the optimizer statistics had been built during the time when the table was empty. So the optimizer was doing the full scan rather than the quick scan type. And because it's doing the full scan, when it was created, we had like 100,000 lines, but when we moved into the production, it was like million lines. So now it started doing the full scan. When it started doing this full scan, the end user experience was 30 seconds response time coming up. So what we have to do it is we refresh the optimizer statistics against the production data, current production data, and then we ran the application. Because it is now refreshed, it started taking the new algorithm, and then we had the refresh stats coming in, and the response time was really quick, as compared to the previous, because it has the old optimizer statistics used. The second is 10 a.m. freeze. Now, this particular situation, the distributor reported a daily freeze at same time on the day. So, for example, in the morning, he's saying the slowness is occurring. Every day morning, the slowness is occurring. So we ran ST039, and we find out that wait time is the main reason of slowness, not the DB or any other. So we ran SM66, and it showed us that there is a particular batch which is getting executed during this particular window. Now, what we have done is we had a discussion, and then we moved this particular batch little bit ahead of time, so that it is not coming, so that it get completed during the night time, and it is not getting extended during the daytime when the users are getting onto the application and started experiencing the slowness. The other is Singapore only. Now, this particular challenge that we have checked is, we launched the application, it was working perfectly all right when you are experiencing on the main areas like headquarters and main markets. But when it go to the farther market like Asia Pacific market, the slowness started looking in, and people started complaining that the application is responding slow. So when we started digging into the details, we identified that we might need to have a different or additional data centers catering the further clients, so that like they will get quick response and all those things. So the quick fix was, we added more what you call systems or regional caching for that particular area where the slowness was experienced. The other one is the phantom ERP problem. One of the finance screen was taking way long time to load, and everyone was complaining SAP is slow and all those things. So what we started looking in is, we started getting into the um, distributed mode of that particular application, and we started noticing that the integration part of this particular functionality is what causing the slowness in the application. So we started increasing the cache time and started doing more caching, so that that particular slowness on the page can be addressed. So caching is one of the key solution that we have implemented in this particular challenge. So these are some of the key challenges that we have seen in different kind of like implementations. Now I'm moving down to the next slide. Now, what is new in coming year, or in rest of the year and coming year? So everyone knows that ECC the support will be getting over by 2027. So a lot of migrations will be happening. Rise, SAP on Rise is coming, and everywhere you can see this is getting implemented, and the shared responsibilities, because it's on cloud, you can see this happening. Then there is like embedded AI Joule is getting implemented, and then cloud ALM and open telemetry. So these are the new things that is coming in the area of SAP. And whatever we have seen till now, the the three principles that carry the load. The first one, you should decompose before you make any decision that a specific system is causing the slowness. So please go ahead and decompose your response time, and then based on that you can take a best guess which particular component can be the area of interest for your RCA. Then establish a baseline at go live. So when you go live, first week, try to create a baseline. And then this is something which I tell to everyone: make performance as proactive, not a reactive. So try to have performance throughout your life cycle. And it is not only like at the project level you do the performance. Even after performance is done, performance testing is done, you continue this particular practice where you check every weekly your reports, errors, and production issues, and have some kind of like database which will help you out in doing certain kind of proactive measures in your performance engineering services. So these are the three principles that carry the load. Now coming down to the Q&A.
Yes, thanks Nagarjuna for insightful webinar today. So moving towards the key Q&A section. So very first question in our Q&A section from the Teddy side is: a transaction that was sub-second during testing suddenly takes 30 plus seconds a few days after go live. How do you prove this is a statistics or execution plan problem rather than a code or infrastructure problem? And how do you fix it?
Nice one. I mean, this is really a good question. Um, what we have to do? So first we need to, again, if you remember, like, we have to first decompose it. We need to first run st03n, and we need to find out the affected time window. If db require if db request is dominant in your response time, then you might need to run what you call the db check and find out which top queries are causing this particular issue. So we need to first decentralize or break your response time. And if db request time dominates, the response time split, then the bottleneck is the DB, not in ABAP code or any other capacity. Go to DB cockpit, find out the expensive statement, and then look into that particular what you call MSQL plan cache, and then look into the elapsed time and find out which is the dominant elapsed time. The root cause is almost or always same pattern. Optimize the statistics and the SQL plan cache were built during the data load. So production volume hit 100 million or same plan, still pin the cache. So the fix here, I mean, refresh your what you call optimizer statistics, and then replan it. This is one of the area that I can see that you can resolve this kind of like issues.
Great. Yeah, thanks, Nagarjuna, for answering the question. The next question is, let me project it as well. Your monitoring dashboards all show green, but users are still complaining the system is slow. How do you explain that, and what do you check?
Same thing. I mean, I have given that example even during this particular session. Your what you call metrics are always green, but you are getting complaints saying that application is slow. So this particular example clearly tells that your metrics are based on average response time, not on the percentiles. We need to start looking into the percentiles, the high percentiles like percentile 95 or percentile 99, where you have exceptions captured, and that is what you need to look and address it. So if this is happening, it's always good that we should go back to the percentiles and recalibrate all our metrics based on those particular what you call percentiles. Now, I mean, if you see the example that I have given in our presentation, that one of the client was having a good experience, but other guys were having a bad experience. Now, what is the bad experience? They are far from the origin servers or the location where the application is getting hosted. So these guys are less in numbers. So no one, their response are not getting captured as part of average. So what generally happen is you start looking into the P95s or P99s, and you will come to know which particular regions or area is experiencing those big numbers. Now, once you see the big numbers, you will understand that geolocation is causing the slowness, not your application or not your code or infrastructure. Now, once you understand that your geolocation is playing the role, then you start looking into the solution. And one of the solution that we have discussed during the session was caching. So you start caching near to those areas which are further, and then that can help you out in addressing all this particular slowness. Yeah.
Thanks again, Nagarjuna. The last question in the panel is how on cloud or virtual servers, the CPU usage looks moderate, but the system still feels uniformly slow. What could be causing that?
Right. Now here you need to understand how the infrastructure work. Now, when you go on cloud, you'll be working on virtual machines. So virtual machines share the hardware. The CPU, say on a virtual machine, the CPU busy percentage only tells what happened while your virtual machine was actually running on a physical core. It doesn't tell you if your virtual machine was ready to run but had to wait for the physical CPU getting allocated. Now, what happened, in virtual machines, the CPU is getting shared. Now, that wait time of what you call your virtual machine to wait to get the CPU is one of the slowness that is causing the slow response time, and it is invisible to normal OS level monitoring. So if CPU usage look moderate but everything feel bit slow all day, the next place to check is isn't inside SAP. It is your hypervisor, or you have to go into your VMware or Hyper-V and start looking into the real infrastructure allocation. If the high CPU, it means physical host is oversubscribed or had a noisy neighbor. We say this term noisy neighbor because your VM is running average, but your next VM is using entire infrastructure, which is causing slowness for you to getting that particular resource allocated. So start looking into those areas, and it can help you out in addressing these issues, which is not SAP, but SAP is sitting onto these things, so causing your slowness. Yeah.
Great. Yeah, thanks. That's all for today, Nagarjuna. It was a wonderful session, definitely.
Thank you
And
so much.
thank you. Thanks a lot for sharing your insights on performance testing. And thanks to all the attendees as well for staying with us throughout the session. And if you are looking to improve post-go live performance, strengthen release confidence, or accelerate your SAP transformation, connect with ImpactQA's experts. We are here to help. You can email to us at solutions@impactqa.com. You can scan the QR code as well. Above all, I have shared the link to have to get the meeting scheduled with us. You can check it out in our Q&A section itself. Thanks a lot.
Thanks, everyone. Thanks, Pooja.